On this Ram 1500 Classic with the 5.7 Hemi P0302 means the PCM is seeing a misfire pattern tied to cylinder 2. In plain terms, the crankshaft is not accelerating evenly on that cylinder. The truck may run rough, may feel weak under load, and the MIL may illuminate or flash depending on how severe the misfire is. Broadly, this can come from possible ignition, fuel, air, engine mechanical, VCT or valve lift related issues, oiling concerns, or wiring and connector problems. Before chasing the fault, make sure the misfire monitor can actually run. The monitor gates include fuel level above 12%, battery voltage above 9 volts, ambient temperature above -23 degrees C, -4 degrees F, coolant temperature at engine start above -7 degrees C, 4 degrees F, or if the start engine temperature is below threshold engine temperature reaching 21 degrees C, 8 degrees F, with engine speed between approximately 400 RPM and 6,200 RPM. Also remember, during a severe misfire with a flashing MIL, the PCM can disable the affected cylinder's injector to protect the catalytic converter, so a high-load misfire may seem to hang around briefly when the engine comes back to idle. Start with the basic pre-diagnostic checks before getting deep into cylinder-specific testing. Then turn the ignition on, pull all stored information with the scan tool, and record the DTCs along with the captured operating data. Drive or operate the truck under those captured conditions and pay attention to when cylinder 2 starts missing. While the misfire is happening, watch the downstream oxygen sensors and the misfire monitor. If the downstream oxygen sensor readings stay low, think lean direction, lack of fuel from a plugged injector, or a fuel system issue. If they stay high, the converter is seeing too much fuel, which can point toward lack of spark or a leaking injector. Confirm on the misfire monitor whether cylinder 2 is showing excessive misfires right now. If it is not active, treat it as an intermittent condition instead of forcing the rest of the test. If it is active, look at the other active or pending codes. If there are fuel system, ignition component, air handling, VVT or VVL faults present, handle those applicable diagnostics first. If none of those are present, the next return point in the path is unclear, so pause, recheck the earlier diagnostic path, and avoid guessing before moving on. Once the active cylinder 2 misfire is confirmed, do a careful inspection before narrowing in on parts. Look for anything that can disturb crankshaft speed or cylinder balance. Belt and accessory drive problems, poor sensor mounting, poor connector or terminal fit at key engine components, corroded PCM power or ground circuits, vacuum leaks, intake or exhaust restrictions, internal engine issues, moisture around ignition parts, fuel supply or fuel quality concerns, and load-related operating problems. If you find a problem, repair it and verify the repair. If no problem is found, the no problem return point is unclear, so stop and recheck the earlier path rather than assuming a branch. After the path is confirmed, check the engine and intake manifold for vacuum leaks. A vacuum leak can affect one cylinder or more than one, depending on where it is. If an intake leak is found, repair the leak and verify the repair. If no leak is found, check fuel quality. Look for water, wrong fuel type, old or contaminated fuel, low fuel, and confirm the ethanol level with the proper fuel check. If the fuel is the issue, replace the fuel and, if needed, flush and clean the fuel system, then verify the repair. Next, test for a clogged or leaking injector. Treat this fuel work seriously. The fuel system stays under constant pressure, even with the engine off, so release fuel pressure before testing or servicing any hose, fitting, or line. Install fuel pressure decay tester 8978A to the fuel rail. Turn the ignition on. Let fuel pressure reach maximum and stabilize, and record that as the starting pressure. The ignition may need to be cycled off and on a couple times to get maximum rail pressure. With the scan tool, actuate the cylinder 2 fuel injector while watching the gauge, and record the ending pressure. Then repeat the same process on several good cylinders that are not misfiring. Start each injector actuation from the same starting pressure so the comparison means something. After each injector actuation, start the engine to clear fuel from the cylinder. Skipping that can damage the engine. If the ending pressures are about the same across the tested injectors, move on to spark testing. If cylinder 2 stands out, use the direction of the pressure drop. Too small of a drop means check for debris in the fuel rail or injector and repair as needed. Too large of a drop points toward a faulty or fouled injector concern. After any repair, verify the repair and confirm the code stays gone. If injector pressure drop looks comparable, move to ignition output. Turn the ignition off, remove the fuel pressure decay tester, and reconnect the fuel lines before continuing. Remove the ignition coil from cylinder 2, reconnect the coil harness connector, and disconnect the fuel injector connector for the cylinder being tested. Install a spark tester on the ignition coil. Crank the engine and watch the spark. A faulty coil or plug can miss at idle or only under heavy load, and one failed coil or plug will usually show up as a single-cylinder misfire. If you have a crisp blue spark, continue with spark plug, cylinder, and mechanical checks. If you do not have a crisp blue spark, go into the ignition power and control circuit tests. With good spark present, turn the ignition off and inspect the cylinder 2 spark plug and cylinder. Look for cracks, carbon tracking, oil, coolant, or excess fuel fouling, plug gap out of specification, and loose or broken electrodes. Also check for signs of oil or coolant in the cylinder. If those conditions are present, replace the spark plug, and if oil or coolant is in the cylinder, diagnose and repair the cause before verification. If the plug and cylinder inspection passes, perform a compression test on all cylinders and compare the known good cylinders against cylinder 2. If compression is not within specification, use a cylinder leak down test to determine whether the cause is in the valvetrain or combustion chamber, repair as needed, and verify the repair. If compression is within specification, swap the cylinder 2 spark plug with a known good cylinder, or replace the plug if access makes swapping impractical. Start the engine and watch the misfire monitor. If the misfire follows the plug, replace the spark plug. If the plug was already replaced and the misfire is gone, the plug repair is complete before final verification. If the misfire does not follow the plug, clean carbon from the valves and combustion chambers using MOPR combustion cleaner. After driving and clearing the cleaner from the engine, erase the codes, reproduce the captured conditions, and watch the misfire monitor. If the misfire does not return, the carbon cleaning repaired the fault. If it does return, check the oil level and oil condition before continuing. Oil level, oil pressure, filter specification, oil cleanliness, contamination, viscosity, aeration, or mechanical tolerance problems can mislead this diagnosis, so repair any oiling or mechanical condition found and verify. If those checks pass, test VCT solenoid operation. Reconnect PCM-C2, turn the ignition on, and measure the voltage on the VCT solenoid control circuit at the solenoid connector. The VCT solenoid driver circuit is a 12-0-volt PWM circuit, so the voltage should be present and should match approximately to the percentage selected. If it does not, repair the VCT solenoid driver circuit for an open or short to ground and verify. If it does, visually inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts. These parts may not always show up during compression testing, and the operating condition where the misfire appears can change with the type and severity of wear. If a cam, rocker, or spring issue is found, perform the appropriate repair and verify. If no issue is found there, move to the final connector and harness inspection path. If cylinder 2 did not have a crisp blue spark, go after the ignition coil circuits. Keep clear of the fan, pulleys, belts, and loose clothing whenever the engine is operating. Turn the ignition off and disconnect the ignition coil connector. Turn the ignition on and use the scan tool to actuate the ASD relay. With a 12-volt test light connected to ground, probe the ASD relay F0302 output circuit at the ignition coil connector. If the test light does not illuminate brightly, Stop all scan tool actuations and repair the open or short to ground between the PDC and the ignition coil connector, then verify the repair. If it does illuminate brightly, check the coil control circuit. Use a 12-volt test light connected to a 12-volt source. Back probe the coil control circuit at the ignition coil connector and crank the engine for 5 seconds while watching the light. If the light blinks brightly, replace the ignition coil and verify. If the light stays on constantly, check the coil control circuit for a short to ground. Turn the ignition off, disconnect PCM-C2, and use the GPEC diagnostic adapter 10436 on the engine harness side. Do not probe the PCM harness connectors. That can damage the terminals and create poor terminal contact. Check continuity between ground and the coil control circuit at the ignition coil connector. If continuity to ground is present, repair the coil control circuit for a short to ground and verify. If there is no continuity to ground, continue to the final connector and harness inspection path. If the control test light stayed OFF constantly during cranking, check the coil control circuit for an open. Measure resistance between the ignition coil connector and the GPEC adapter. If resistance is below 3.0 ohms, continue to the final connector and harness inspection path. If it is not below 3.0 ohms, repair the coil control circuit for an open or high resistance and verify. For the final path, inspect the related PCM and component harness connections. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Look for connector seating problems, damaged locks, corrosion, water intrusion, seal damage, bent terminals, overheated or discolored terminals, push-back terminals, spread terminals, and poor terminal tension. Repair anything found. Then reconnect every connector fully and make sure the locks are engaged. Erase the codes. Operate or test drive the truck under the conditions that run the monitor, and read the codes again. If P0302 returns after this connector and harness path, replace and program the PCM, then verify the repair. If P0302 does not return, the wiring or poor connection problem has been repaired. Keep the logic clean. Prove the cylinder 2 misfire is active. Separate fuel, spark, mechanical, VCT, and wiring causes in order, and verify after every repair. For more diagnostic training, visit stepdiagnostics.com.